welcome back. All right, let's look at number 24, 25, and 26 of our review. What are drawn in the figure below? So let's see, if I've got altitudes, I should be starting at a corner and hitting the opposite side at a 90-degree angle. So I don't have little boxes, so I definitely don't have altitudes because I don't see that I'm hitting at 90-degree angles. If I have angle bisectors, I should see arcs on my angles showing that they've been divided in half. I don't see that. And again, with perpendicular bisectors, I should be leaving midpoints, which I am leaving midpoints, right? Because if I have double tick marks, this is a midpoint. Triple tick marks, this is a midpoint. Single mark, this is a midpoint. So I do have midpoints. So I am bisecting, but I don't have 90-degree angle markers. So I can't see that I am perpendicular. Okay, so I'm not perpendicular bisectors, which means I have to be medians, which is true. I'm starting at vertices, and I'm going to midpoints for each one, from a corner to a midpoint, from a corner to a midpoint. So these are all medians, which means I have made a centroid. Remember, your centroid is your balancing point. Your center is center of all the centers, and it's dividing each median into thirds, right? Where I have the shortest third by the side, my short by the side. I remember they both start with S, short and side. And then the other two go toward the vertex. So the one that's very long is by the vertex. Okay? So when I look at 26, it says if the distance from O to point D is 5, so from O to D, if my short piece to the side is 5, well, then I know that there's two of them here, so this has to be 10. What's it asking me for? It wants to know how far is it from C to O. Oh, I just found it. It's 10. Okay. The next question says, if A to E is 18, find AO and OE. Sounds like a song. AO, OE. All right, let's see. A to E. A to E is 18, so that whole thing is 18, and I know it's divided into thirds. One is by the short one by the side, and then two of them are the very long part by the vertex. Okay, so I'm going to take that 18 and I'm going to divide it into 3 parts. Each part is going to be 6, so my short part is going to be 6. My long part takes 2 short parts together, so that's 12, so that together I get my 18. So the distance from A to O is 12, and the distance from O to E is 6. Okay? All right, let's go ahead and squeeze this last problem in on this last video. All right, when I look here, the perpendicular bisector of a segment divides a segment into 2 congruent segments at a 90-degree angle. Add a 90-degree angle box and tick marks to the figure to the right so that line AC is perpendicular bisector of segment BD. So it has to be, I want this one to be bisecting this one. So I know I'm going to have a 90-degree angle, and I know it has to bisect this segment. Okay, done. Circle the following, which must be true. Not sure why there's a question mark there. The distance from D to E equals the distance from B to E. Let's see, D to E is here, and B to E is here, and yes, we put tick marks on them because it's been bisected. So I can circle that one. That is true. The next one, I'm just going to move to the right. AE is equal to CE. So AE, this one here, is equal to CE, this one here. Now, this was my bisector, which means this one was cut in half. But C could have been real close, C could have been real far, A could have been real close, A could have been real far. There's nothing that tells me these two have to be equidistant from that intersection, like the one that's being bisected does. So this one does not have to be true. Okay, look, now we have some triangles that we're going to see if they're congruent. Triangle ADE is congruent to triangle ABE. So let's see where these triangles are. ADE. So that's this side right here. And ABE, so that's this side right here. Are these two blue triangles congruent? Well, let's see. They definitely have a side congruent. If this is 90, then this side is also 90. And then they share this side here, so by the reflexive property, that's the same for both triangles. So we have a side and an angle and a side. So yes, those triangles are congruent by side, angle, side. I could prove that. Okay? All right, and then the last one here, triangle ABE is congruent to triangle CEB. Let's see, ABE, ABE. So that's this blue triangle that I already had. That's this one. I'm going to redo it this direction in green. And is it congruent to triangle CEB? So CEB. That's this triangle here underneath. So is the top triangle congruent to the bottom triangle? So again, I know I have this reflexive side that's the same for both triangles. I have a 90-degree angle there. I have a 90-degree angle here. But the last time we were able to say it because I also had another side, so I had side, angle, side. But remember, we said here we can't prove that AE and CE are the same. So I don't have any way of saying that these two are the same. I don't have any way of saying these two are the same. So that means, no, I can't prove that those triangles are the same. The two triangles on the same side of the bisected segment are going to be the same. The two triangles below the bisected would be the same. But if one's below and one's above, the one with the tick mark, those are not going to be the same on either side there. Okay? Hopefully that helps. Hopefully you feel like you're ready and confident to take the test. If you have any questions between now and when we take the test, please make sure you ask during sync time or attend tutoring. Thank you so much for watching.